Take two because issues. You looked at the title, you saw the icon. Yeah, I'm doing another video on this. Here we go. The 2200 or 2100 feet per second rifle versus pistol velocity upon impact for bullets, the wound cavity cutoff theory. When people talk about pistols and rifles, sometimes they mix it up besides the physical shapes, sizes, and legal definitions that are really just worthless these days. Thank you very much, ATF weasel worder. But one of the things that gets brought up is the speed of the bullet, and not why they're the shape they are and what they're for. And this is such a fuzzy subject matter that I haven't been able to find any really clear-cut answers, because there really aren't any. But here we go with pistol ammunition logic and theory about stopping power and functionality. Heavy bullet, speed, fast, and delivering the energy into the target quickly for stopping power. This is another vague subject, endlessly debated. And the idea with this is, I'll just bring up a simple answer here. When a soft lead, non-jacketed bullet, doesn't matter if it's hollow point or not, hits something, it will expand or deform at a lower velocity than the minimum, seemingly minimum, 1100 to 1300 feet per second or faster needed for jacketed hollow points. And the idea is, if a bullet doesn't deform, it might go all the way through a target and then hit something on the other side, even if it just bounces off of them. And the idea is, if you're going to shoot something, dump all the energy that this projectile carries into the item, whether it fragments and splinters and cuts into organs, or it just expands and comes to a dead stop, pun intended, inside of the body of the animal or human you're shooting. That's the logic with them. And even people who mention the 2200 feet per second cavity function talk about doing these other things instead. Was this some secret hidden math thing? Well, I'm going to bring up a simple answer and question at the same time. Why are rifle wounds, rifle being very vaguely defined, more devastating than pistol or carbine wounds? Why? When you can have a rifle wound go all the way through a person and produce a lot of damage. Now, the first thing that comes up is someone will mention hydrostatic shock, Mach numbers, and ripping and tearing. Under 2,000 feet per second, approximately. There's a lot of variations, but definitely under 2,000 feet per second, no matter what the shape or size or mass. Bullet impacts crush flesh in front of them, creating a relatively small track of damage. But it crushes in front of it. See also jet aircraft traveling under Mach 1. The pressure builds up in front of the aircraft. But at Mach 1 or past it, the compressed mass flies past them and they can slip through and the efficiency might increase. But that's 2,000 feet per second. Mach 1's around 1,000, right? At 2,100 feet per second, exceeding the seeming Mach number-like number, the bullet impact creates a shock wave around it that has the speed that this is the quote, exceeds the elasticity or rate of expansion, contraction, and recovery for flesh. So a temporary wound cavity would become a larger cavity, and it wouldn't be temporary. You can have a bullet, any mass, any volume, whatever, and it'll create a temporary wound cavity where everything stretches out of the way. What is in it when it does that? And then it will collapse down. Again, what was in it when it did that? And in this case, if you go over 2,100 feet per second, which seems to be a magic number, but that's the minimum number for this effect, this cavitation can become permanent cavitation. Again, what is in the cavity? Is it really a cavity? And it'll become non-temporary. Is this based on being Mach 2 in the first couple of inches of flesh? But wouldn't any bullet drop below the magic speed on impact? Or does it? at 2100 feet per second inside the tissue. Mach 2 is 2250 feet per second. There's this magic number below 2200, suspiciously, and down to 2100. Mach 2 is 2250, so we assume it's Mach number. It is and it isn't. 2100 feet per second is Mach 1.866. It's not Mach 2. Based on 1,125 feet per second, or 766 miles an hour, or whatever. Now, and of course it works out too, if you're curious, it's not the right number, but it's a good yardstick. 666 knots. It's not really, but I've done that before in a couple of videos. Or 1,235 kilometers per hour. What is transonic? This is an important number. 0.72 to 0.21 Mach. 0.72 of Mach, 72% of the speed of sound in any medium up to Mach 1 is considered transonic. Depending on the medium, it can be a different number. This is the mythical 707 or 70% mark or 3/4 mark between whatever upper limit or transition point, it's not a limit, and another. What is the speed of sound in the medium we're talking about? The medical ultrasound average propagation speed, or speed of sound in body tissue, is 1,540 meters per second, or 5,000 feet per second, 5,052.5 feet per second inside of tissue. So at 2,100 feet per second, you're at Mach 0.45, and at 22, you're getting close to 1/2 Mach number inside the tissue. Guess what transonic speed is in flesh? It's 0.489 multiple decimal places to 1. So at 1/2 Mach in flesh, and at nearly exactly, almost exactly Mach 2 in air, the transitioning effect from going from Mach 1 in this medium to Mach 0.5, almost exactly the transonic cutoff point in flesh. The bullet is transitioning and becoming polytransonic. I had to look that up. Or doubling the Mach number in air to 1/2 the Mach number in flesh, which is 1/2 in flesh and 2/1 external. It's a doubling point. When you're traveling at Mach 1 or Mach 2, you can go through a transition point in air. Every time you hit the Mach number, depending on the shape of the object, airplane, bullet, whatever, it creates a different bow shock pattern, and more importantly, that buildup of pressure or material in front begins to slipstream easily, which means at 0.5 Mach, or 0.45 Mach in this case, through 0.6 Mach in flesh, or happenstance, around 2 times the speed of sound. A bullet is transitioning at such a rate that it is slipstreaming, but pushing still some air into the wound, so you have an air cavity, and the flesh forms a bow shocking area where it will not compress the tissue and slow the bullet down, but pushes it out of the way, creating a shock wave filled in with air that has now been pulled to transonic in air at anywhere from 0.7 to 1.4 Mach in the tissue. And then it drops down to lower speed. The air itself becomes the projectile and goes transonic and then subsonic inside of a wound that is also transonic and then subsonic, creating dozens and dozens of bow shock reciprocating effects or resonances inside the tissue. It's not a magic number. You can get a similar thing at Mach 1. Well, no, because tissue has a speed of sound at 5,000 feet per second. See also the bizarrely bad cavitation effect at flesh Mach 1, or transonic at 4,000 feet per second to 5,600 feet per second, that you do see in some wound ballistics. So, the mythical 2,200 feet per second through 2,100 feet per second happenstance is 1/2 or around 1/2 Mach 1 in flesh and is Mach 2 in air, and has the rather devastating effect of causing the air to be transonically pulled into the now permanent wound cavity, because the temporary wound cavity from a Mach 1 only or Mach 2 or less bullet doesn't drag in air as much, so that temporary wound cavity isn't an air cavity, it's a vacuum. And because of the speed it's going in tissue, it's not going fast enough to push the tissue out of the way and create a real bow shock effect. But because the air is coming with it, that does have the effect of pushing it out of the way rather than crushing it. It still creates a crush path because it is still subsonic. It's not 5,000 feet per second, but the air is able to keep it expanded and causes more tearing and damage. Now, this is more of a question than an answer, because no one has actually addressed the fact that you're dealing with two different mediums with two different Mach numbers. See also light transitioning through water or glass, creating a bending effect, because the equivalent for light is its index of refraction caused by the speed of light being different in water, air, glass, and plastic. Propagation effect. And yes, if you have a bullet going, again, the number is, I gotta find it again, 5,052 to 5,053 feet per second, you get ridiculously overdriven reactions. You might have noticed that rifles, you can get rifles that'll go that fast. You can also get pistol bullets that go that fast. Warning, 22 caliber hollow point soft lead bullets exist that can go 22 to 2,500 feet per second. You can get 9 millimeters that rate. You can get, yes, there is one, a shotgun slug. It's basically a 70 or 80 caliber, depending on which one you get, bullet. Can go almost Mach 2. You have to have an overbuilt gun. It's not really a shotgun anymore. It's a rifle. It's a stopping rifle. And yes, heavy bullets do more damage, etc. And yes, you can get a .223 bullet jammed into a 22 caliber rimfire cartridge that's long enough, spaghetti round it's called, that you can almost get AR-15 velocities out of a single shot. And it'll confuse the shit out of a ballistics person. But the speeds here happen to be quasi-resonant points at half Mach and double Mach. And there's another resonant point at 0.3 Mach in flesh, which would work out kind of like 1,400 feet per second, which is also a magic number. These magic numbers are used as points where you find amounts of damage. For instance, a good example is the FBI gel test showing that number 4 buckshot is sometimes more effective than double-aught for stopping power. Recommendations. I've actually discussed this on the channel before, but I may have actually succeeded because it was an auction site, quasi-auction. It's not really an auction site, it's fake. Getting my own 12-gauge pistol. It's a flare gun. It doesn't matter if it's broken. I just want to have one to glue together to use it as a reference point to make the ultimate terror. A double action trigger system for it, because I don't want to pull the hammer back. I want to have it to where I want to design a flare gun that will float properly with a cartridge in it that does not require that you do anything but pull the trigger, not even moving a safety out of the way. You load it, the safety's off. That's how it works. And I want to be a competitor by designing it to be a 3D printed firearm. The only 3D printed firearm on Earth that I know of. But while I'm at it, I'm also going to next month, for the same cost, because I found one cheap, $14 is cheap, a revolver that can do 8 shots that can fire 22 Magnum. 22 Magnum hollow points are capable of causing an overdriven level of damage to a target. I don't want to hurt anybody. I'm going to be firing blanks. 223, no, I'm going to be firing 209 primers out of it because they'll fit. And I'm going to make it to where it'll fire center fire and rim fire by having floating pins, because that's another project I want to do. And then when I'm done doing these projects and playing around, I'm going to put up the information on the net and then throw them away. Don't need them. I'm in a safe country. Yeah, we have mass shootings. That's what you concentrate on instead of mass shootings and wars or genocide or ethnic cleansing or gang activity and violence. I'm in a safe country. I don't need a gun. But for those of you who are curious, don't underestimate a 22 mag. That's the video. Thanks for watching. Good luck with that. The thumbnail is actually an air gun. Bye.